we're asked to write the following numbers as complex numbers. A complex number is a number in the form a plus bi, where a and b are real numbers and I is the imaginary unit. Remember, I is equal to the square root of -1. As an example, 5 plus 2i is a complex number. Every complex number has two parts. The real part, which is the part without the I, and the imaginary part, which is the part with the I. So for number 1, we're given 3.4. 3.4 is a real number. There is no imaginary part, which means in the form a plus bi, a, the real part, is equal to 3.4, and for the imaginary part, b must equal 0, which means 3.4 is equal to 3.4 plus 0i, written in the form of a complex number. 0 times I is still 0, and therefore this does equal the real number 3.4. However, this also shows all real numbers are in the set of complex numbers. Number 2, we're given the imaginary number -7i. Because an imaginary number does not have a real part, that means in the form a plus bi, a equals 0, -7i as a complex number can be written as 0 minus 7i. This shows all imaginary numbers are in the set of complex numbers. Next we have 6 plus the square root of -4. The first step here is to simplify the square root of -4. And let's do this on the side. The square root of -4 is equal to the square root of -1 times +4, which equals the square root of -1 times the square root of 4. And now we simplify. The square root of -1 is equal to I by definition. So we have I times the square root of 4 is equal to 2, because 2 squared equals 4. So the square root of 4 also simplifies perfectly. And I times 2 is equal to 2i. This is all we need in order to write 6 plus the square root of -4 as a complex number, or in the form a plus bi. This is equal to 6 plus 2i, where 6 is the real part and 2i is the imaginary part. For the last example, number 4, we're given -3 minus the square root of -18. The first step is to simplify the square root of -18. Let's do this on the side. The square root of -18 equals the square root of -1 times +18, which equals the square root of -1 times the square root of 18. To simplify the square root of 18, let's look at the prime factorization of 18 to identify any perfect square factors of 18. This equals the square root of -1 times the square root of 2 times 3 times 3. Well, 3 times 3, or 3 squared, is a perfect square factor of 18. So the square root of -1 simplifies to I. So we have I times the square root of 3 squared is equal to 1 factor of 3. So we have times 3 square root 2. We can write this product as 3 square root 2i, or 3i square root 2. But notice how in the form of a complex number, we have b times I, where b is a real number. So we'll go ahead and use this form here, where the I is on the right. So -3 minus the square root of -18 as a complex number is equal to -3 minus 3 square root 2i. I hope you found this helpful.